Assalamu alaikum wa rahmatullah. During this video we are going to complete our lesson about oxidation and reduction, about the idea of the H plus H2 redox couple. By the end of this video you will be able to identify the place of hydrogen couple with respect to that of metals on the axis of electrochemical classification. The materials needed during this session are your pen and your chemistry notebook. Let's remember what we talked about in the last period. We said that the redox couple of hydrogen is represented by H plus H2. We also said that the half reaction of hydrogen couple is 2H plus 2 electrons give H2, or H2 gives 2H plus 2 electrons. We said that the reaction between metals and acids is represented by M, which is the metal, plus 2H plus, which is the acid, react together to produce Mn plus, which is a metal ion, and H2 gas. Also, we said that H2 gas can be identified by producing a detonation or a pop sound in the presence of a flame. Now, do all metals react in the same way with acidic solution? To answer this question, let us watch the following video. Don't forget to record your observation on a draft paper. Before we start the video, here we have several metals. In this test tube we have calcium, and this we have Zn, here we have Cu, Mg and Fe. We're going to add acids to all these test tubes. Let's observe what happens. Now, let's record our observation in a table. When we placed a copper metal in the acid, what was observed? No change took place. It means there is no reaction between copper and the acid. When we placed iron in the acid, a little change was observed and few bubbles were produced. Also, when we put magnesium in the acid, there was a very significant change. And when zinc was placed in an acid, there was a significant change in the test tube. This leads us to a question. Do all metals react with acid in the same way? Look at the observation. There are different observations for different metals placed in an acid. This leads to the answer, which is no. Which metals react with acids? Look here. Copper does not react with the acid, while iron, magnesium and zinc react with the acid. Don't forget that the reaction takes place between the strong oxidizing agent and the strong reducing agent. So the metals should have more reducing power than H2. Now, to place the couple H plus H2 on an axis of electrochemical classification, we will go back to the results of the experiment that we have seen in the video. Here, a slow reaction took place between iron and the acid, a fast reaction took place between magnesium and the acid, and another fast reaction also took place between zinc and the acid. What does this mean? This means that Fe, Mg and Zn metals are stronger reducing agents than H2 because they had reduced H plus ion, while no reaction took place between copper and the acid. This means that copper metal is a weaker reducing agent than H2 since it does not reduce H plus ion. All these observations allow us to place H plus H2 couple between Cu2 plus Cu couple, Fe2 plus Fe, Mg2 plus Mg, and Zn2 plus Zn couples. Now, how can we classify these redox couples? Now, we will place the first redox couple, which is H plus H2. Here, we said that no reaction took place between copper and the acid. What does this mean? This means that copper has less reducing power than H2. So we must place copper here above H2. And also we said that magnesium undergoes the fastest reaction with the acid. This means that it has the greatest reducing power. So we place it here. Okay? Mg2 plus Mg. Also we said that a fast reaction takes place between zinc and the acid. It is a fast reaction, but it is slower than the reaction between magnesium and the acid. This means that Zn has a greater reducing power than H2. It has a greater reducing power than H2, then it must be placed under H2, but it has less reducing power than Mg, so it is placed here. Finally, a slow reaction takes place between Fe and the acid, so although it has a greater reducing power than H2, but it has a lower reducing power than Mg and Zn. So this is the position of Fe2 plus Fe in the electrochemical classification. Now, let's sum up what we have learned about the H plus H2 couple. First, we said that the hydrogen ions H plus and the hydrogen gas H2 form a couple H plus H2 such that 2H plus plus 2 electrons are reduced to give H2, or H2 is oxidized to give 2H plus plus 2 electrons. Also, we said that acidic solutions can react with metals whose couples fall below the H plus H2 couple in the electrochemical classification. Finally, we said that the gamma rule predicts whether a reaction between H plus ion and a metal M can occur. The metal must have a greater reducing power than H2. Now, we will solve exercise 5, page 55 on your chemistry book. Part A says, among these metals, which are those attacked by hydrochloric acid? The metals are Zn, zinc, Au, gold, Fe, iron, Ag, silver, Al, aluminum, and Cu, copper. Look at this axis of electrochemical classification of the redox couples of these metals and the redox couple H plus H2. All the metals that have a greater reducing power than H2 can react with H plus according to gamma rule. Then the metals that can react with H plus with acid are Zn, Fe, and Al, since they are found below the hydrogen couple on the electrochemical axis, so they can be oxidized by H plus ions found in acids. In part B, we are asked to write the half reaction corresponding to the redox couple Al3 plus Al, Na plus Na, and Mg2 plus Mg. It is a very easy question. For the first couple, which is Al3 plus Al, it is Al3 plus 3 electrons gives Al, or Al gives Al3 plus 3 electrons. For the redox couple Na plus Na, we say that Na plus 1 electron gives Na, or Na gives Na plus 1 electron. For the last redox couple Mg2 plus Mg, Mg2 plus 2 electrons give Mg, or Mg gives Mg2 plus 2 electrons. Now part C of this question says, can a copper 2 sulfate CuSO4 solution be kept in an iron vessel? Let's look at this axis of electrochemical classification. What are the redox couples involved in this reaction? Since we have CuSO4 solution, then the first redox couple is Cu2 plus Cu. And since we have an iron vessel, then the second redox couple is Fe2 plus Fe. Then the redox couples involved in this reaction are Cu2 plus Cu and Fe2 plus Fe. Here we can see that Cu2 plus is the strongest oxidizing agent, the strongest oxidant, and Fe is the strongest reductant. So according to gamma rule, a reaction can take place between Cu2 plus and CuSO4 and the iron vessel Fe. What does this mean? This means that Cu2 plus ions are reduced by Fe. Then a reaction will occur between the strongest oxidant Cu2 plus and the strongest reductant Fe, leading to the destruction of the iron vessel. Hence, we can say that a copper sulfate solution cannot be kept in iron vessels. In part D of this question, how do the oxidizing powers of metallic cations and the reducing power of corresponding metals vary? The reducing powers of metal vary inversely with oxidizing power of their ions. Why? Look here at Au3+. It has the strongest oxidizing power, while Au has the weakest reducing power, while Mg, which has the strongest reducing power, then its ion, which is Mg2+, has the weakest oxidizing power. The greater the reducing power of a metal, the lower the oxidizing powers of their ions. The assignment that you should solve after you finish this video is to solve the exercises 238, page 55 from your chemistry book. This video was prepared by teacher Anfal Yassin, recorded by Mr. Mustafa Tlais, and supervised by teacher Hiba Badawi. Thanks for your listening.